Chapter 6, Lesson 44 is going to be on solving exponential functions. So over the last couple of chapters here, so this is the last section in this chapter, but going into the next two chapters, we're going to be solving equations, both exponential and logarithmic. So this is kind of the introduction to that. So with exponential equations for this chapter, what we're going to do is change the equation so that they both have the same base, so that they're both say 2 to a power or 4 to a power or something like that. It may already be done for you, like you'll see in a couple of problems. And then you're going to take the exponents and set them equal to each other and solve. So if I had a very basic problem like this one, 5 to the x is equal to 5 to the 3, doesn't it make sense that x would have to be 3 for those two things to be equal to each other? Well, that's going to be the logic behind doing all of these problems here. Since we already have the same bases, here they're both 5, then that would mean that the two exponents would have to equal each other for those two things to be equal. And so therefore x would just have to be 3. Well, what if the problems get a little bit harder? Okay, what if they don't have the same base? Well, when that's the case, then if possible, you want to make them the same base. So 25, I can write that as 5 squared. So I'm going to leave this as 5 to the x plus 4 and make this 25 be 5 squared to the 7th. All right, 5 squared to the 7th would be 5 to the 14th. You would multiply those two things together. So now that I have the like bases, I would take the two exponents and set them equal to each other. Okay, so x would equal 10. All right. Now, what if you can't take 9 and make it 27 to a power, or 27 and make it 9 to a power? Well, both of those would be 3 to a power. So I could take the 9, make that 3 squared. 27, make that 3 cubed. Now, this one on the left here, you'd do 2 times each one of those, so that would be 3 to the 4x minus 6. And this would be 3 to the 3x plus 12. So you're multiplying 2 to that, and you're multiplying 3 to that. Same bases, set the exponents equal to each other, and solve. So if you subtract the 3x over to this side, add the 6 over to this side, you will get x is equal to 18. All right, why don't you take a moment and think about that one. All right, so on this one, that'll be 11 squared. So this would be to the 12x minus 20. So that means x squared would equal 12x minus 20, again, since we have the like bases. Now, a little bit more difficult solving on this one because we have a quadratic. So because of that, I would take that and move that, the 12x and the 20, to the other side, and either now you'd have to factor or do the quadratic formula. So this one is factorable. So that'll factor to x minus 10 times x minus 2. So that means x would either equal 10 or x would equal 2. So you'd have two answers on this one. Okay, so the problem would come in now. What if you have 2 to the x is equal to 5 to the 3x plus 4, where you can't readily make that be the same base. Well, that's what we'll end up covering in the last couple of chapters. All right, but for this one, you're going to be able to take that and switch it so that they have like bases. So find like bases for both sides of your equation and then set the exponents equal to each other and solve. All right, so that's lesson 44 from chapter 6. Let me know if you got questions.